Here we go. Intro to ellipses. So this first slide, you don't need to write down. It's an overview of the different conic sections that are in this unit. The first conic section is a circle. We spent time in geometry with the circle. The general equation for a circle is x minus h all squared plus y minus k all squared equals r squared. So this is for our circle, the standard form equation. You're going to see some similarities with this equation to the standard form equation for an ellipse. The center of a circle is the h and the k. So inside this parentheses, it's going to be the opposite sign in there. The center is hk, and the other thing it has is a radius. In the equation right there. The thing we're going to focus on today is the ellipse. And then as we progress through the unit, we'd have the parabola. We've spent some time already with parabolas. Within this unit, they go a little bit more in depth with the parabola. And then the new thing is the hyperbola. Hyperbolas and parabolas have a lot of similarities. So again, what I would write down on this slide is just the standard form equation for the circle. All right. Everything on this slide, you don't have to write anything new on this slide. It's just kind of showing you what does the definition of an ellipse look like. A couple things that are important, F1 and F2. These are called foci points. Focus is plural. The foci points happen along the major axes. So this first picture is a horizontal ellipse. The major axis is horizontal. The second picture is a vertical ellipse. Major axis goes vertical. The foci happen on the major axis. So if we had a foci point, it would be somewhere along this major axis. So we just call this somewhere in here F1, and then somewhere in here F2. Then you have a center point. Same thing here as your major axis here in the purple. Somewhere along in here you'd have a foci point and a foci point. This is the all-important slide. Okay, thank you. All right. Two standard form equations. Let's focus on the left-hand side equation. Thank you.
Gotcha.
These are for my absent students.
Sorry.
So the first equation, x squared over a squared plus y squared over b squared equals 1, has some of the characteristics of the circle. When we use this red equation is when this number, and the a number, is bigger, and this number here is smaller. If that's the case, you're going to have a horizontal ellipse. The major axes will be horizontal. From the center to one vertice is a distance of a. So change colors here. From the center to the minor axes, this distance here is the length of b. Then, along the major axes, from the center is a distance c, which we're going to find in a little bit, is your foci distance. How you find this distance c, right here in the green, is by this equation. A squared minus b squared, and then you would square root it.
So like say it was like the opposite of Pythagorean theorem.
Close to that yet? All right. Now, second equation, standard form equation. Is that this number is the smaller number, and that number is bigger. Then we're going to use this blue standard form equation. Notice that the A and B are in different places. So from the center up to this vertice will be your distance A, which we find from the equation. This distance from the center over to the minor axis, half the minor axis length, is a distance B in the purple. The foci points will be along the major axes. This is the major axis, which is a vertical major axis. The foci point will start at the center to the length of C. This green distance is C. Again, we find that C distance from this equation. C squared equals A squared minus B squared. All right, so that's some general information. What we're going to do next is we're going to graph a couple of these ellipses. So I'll do one that'll be the style of the red, and then one will be the style of the blue. Okay? So let's lead us into this slide here. We're going to graph this equation. It'll come up to be an ellipse, and we'll identify where the foci points are. So the first thing you need to look at is to make sure that your equation is in standard form. It is. There is a number 1 happening right there. Then we look to see which denominator is bigger. Is it the first number or the second number? This number is the bigger number, right? And this number is the smaller. So if we refer back to this slide, we're going to use the red standard form equation. So I'm just going to write down the standard form equation again. X squared over A squared plus Y squared over B squared equals 1. Now I'm going to pull apart the A and the B. So here's my equation in the green. If I match it up to the one in the red, x squared, I'm going to change that 9 to a 3 squared in the denominator. So I can find my A in just a minute. Plus y squared over b squared. And b squared is 4. So I'm going to change that 4 to a 2 squared equals 1. Now I line up what is my A and what is my B. There is my A. Here is my B. So my A value, A squared equals 3 squared, so then A equals 3. B squared, I wrote my smart board, B squared equals 2 squared. So then B equals 2. So I'm going to stop there and start to graph it. Now for today, in our notes, we're not going to have any ellipses that don't start in the center. There won't be any horizontal or vertical translations happening today. Tomorrow, yes, there will be. So if you think back to 2 slides ago, the center of this circle, if you don't have an H or K in the circle, then your center is starting at 0, 0. And that's what we're going to see today, okay? We're not going to have an H or K today. So now it says x squared and y squared. All right, so let's go ahead and graph this. So I'm going to stretch this out a bit. So here's 1, 2, 3, 4. 1, 2, 3, 4. said our center doesn't have any horizontal and vertical translation. So the center of our ellipse is at 0, 0. There is no H, there is no K. Since our A, this first number, was bigger than this one, our ellipse is going to be in a position on the major axes as horizontal. All right. The A value that we found down here was a length of 3. So how you graph the first two vertices is you're going to start on the horizontal axes. You're going to count 3 to the right. There's your first vertice. That distance should be 3 units. So from here to here equals 3. Now I'm going to go to the opposite direction. I'm going to go backwards 3 units. So there's my other vertice. The distance from -3 to 3 is a length of 6. That's the length. That's a major axis length, which is 6 units. All right. Now, coming down here, B equals 2. So we start at the center again. We're going to go on the minor axes, so the vertical, 2 units up, 2 units down. This is 0, 2, 0, -2. The distance from the center up to one of those points is your B length, 2. All right, so now we have 4 points. We go ahead and create the ellipse around those 4 blue and green points. So -3, 0, 2, 3, 0, 0, -2, -3, 0. So our ellipse is in the purple. It does ask us to find one other thing. Locate where the foci are. The foci run the horizontal major axes right along there. How we find that? If we head back to this slide, it's here in the green. We're going to use this equation. So I'm just going to go ahead and extend this to find our C. So it's C squared equals A squared minus B squared. So the rule is take the denominator's biggest number minus the denominator's smaller number. So C squared equals A squared minus B squared. So 9 minus 4 is 5. Then we undo the squared by square rooting it. So C equals plus or minus the square root of 5. So now let's go ahead and graph it on our coordinate plane. Again, you're looking at the major axes. So you start at the center. And on the major axes, which is this distance between the blue ordered pairs, we're going to go square root of 5, which is about 2.3, so about there, and then 2.3 to the left, about there. We'll call this F and F. Those are your foci points. What those ordered pairs are in exact form is over square root of 5, up 0, negative square root of 5,